we know a little bit about the different types of rivers that there are and some of their behavior, let's talk about floods. So floods occur when water enters a stream faster than it flows away. And of course, these are going to be commonly caused by rainfall or snowmelt, although every now and then there's other floods like a dam breaks or something like that. I always liken a flood to a traffic jam. You know why you get like really bad traffic on I-45? Because more cars are wanting to enter I-45 than can fit and safely drive away. And same thing happens in a flood. More water wants to enter the stream than the stream can hold, and so you end up getting a flood happening. So these floods, a common misconception is when you hear the term 100-year flood, most people think, well, it happens every 100 years. That's not the case. What the term 100-year flood means is that there is a 1 in 100 chance that a flood of that magnitude is going to occur in any given year. Okay, so a 1 in 100 chance that a flood of that size will happen that year. So if you hear 300-year flood, that means there's a 1 in 300 chance. Or a 500-year flood, a 1 in 500 chance that a flood of that size will occur. This is why you can have 2 100-year floods occur, you know, in back-to-back years, because it's a probability. It's sort of like if you have a coin and you flip a coin, right? You have a 1 in 2 chance that you're going to get heads. And just because you got heads on the first flip doesn't mean that you have to get tails on the second one, right? You flip it once, you have a 1 in 2 chance that you'll get heads. Flip it the second time, you still have a 1 in 2 chance. So same thing. Every year you have that 1 in 100 chance of a 100-year flood happening. So just remember that. All right, why did I put this up here? Oh, different floodplains. So we have the river here, and then we have like maybe a 300-year floodplain here, and maybe a 500-year floodplain up there, because again, there's different probabilities of this happening. So what's going to affect how bad our floods are? There's a number of things that affect flood severity. Of course, it's going to be like quantity of the water entering the river, right? How much rain is falling? Is it, you know, did we get 10 inches of rain or 1 inch of rain? That number is going to be important. But it's also important how fast is that water entering our river system. You know, did we get that 10 inches of rain over the course of 10 days? Or like in Hurricane Harvey, did we get it in half an hour? Makes a big difference, because if you can have the same volume of water falling on an area, but if it falls over a longer time period, that allows the rivers to carry it away without flooding. If it falls over a small window of time, then you're more likely to end up getting a flood. There's also the infiltration rate. Infiltration is the water that soaks into the ground. And different rock and sediment types can absorb more or less water. And so if you have a lot of soil that can absorb a lot of water, well, it'll remove that water from going into the river system. Right? So if you have impermeable rock, water can't go into it, well, all of that water then will go into the river, and you have a better chance of flooding occurring. Topography is important too. Topography is going to affect, like, again, if you have some steep slopes made of rock, the river, the water, the rain that's falling isn't going to have a lot of chance to even infiltrate into the rock. It's going to flow really quickly right into the river. Then there's vegetation that's important. Vegetation does a couple of things. Vegetation is going to absorb some of the water, so it actually sucks up some of the water, and then it gives the water back into the atmosphere here through something called transpiration. So vegetation will actually take away some of the water. But it also can form a physical barrier that slows the water down, right? If we have a whole bunch of, bushes and shrubs and stuff, and the water has to find its way between all of the leaves and branches and things, that kind of slows it down from so rapidly entering our river system. So if you have a place like this, we have these very steep rocky slopes, we're not going to have a lot of infiltration. We're going to have the water flow very quickly down from those slopes and enter the river. So this one, our floodwaters would rise pretty quickly. All right, when we are talking about floods, there's certain terminology that goes with floods. One of these is stage. When we talk about the stream stage, that's the elevation of the water surface in the stream. Okay, so is it 50 feet above sea level? Is it 80 feet above sea level? Whatever that elevation of the water in the stream. When you hear people talk about flood stage, that's when the stream stage gets higher than the banks. Right? The stream banks are what holds it in its normal path where it flows. Well, if the elevation of the water gets higher than that, then we're going to have a flood. So that's flood stage, is where the water elevation gets higher than the channel that's supposed to be holding it. The crest of a flood is the maximum stage. So the crest is the highest rise in water in the flood. And we have a couple of different types of floods that can occur in places. You can have an upstream flood, and these tend to be smaller floods. And what I mean by smaller floods, they only affect a local area of the stream. It's not something where it's like the entire state of Louisiana is flooded. It's not like that. This is going to be this small local flood that occurs. And this is usually caused by locally intense rain, things we call a cloudburst. You get these out west quite a bit, especially in a season called the monsoon season, which is the rainy season there. And that's from July to October. You often get these like afternoon thunderstorms where there's like one cloud that drops a whole bunch of rain. And if that happens to fall over a creek there or a stream there, you could have this local flood related to that small localized weather event. These are also known as flash floods because they rise rapidly and they fall rapidly. So they're going to rise really, really quickly, but they're also not going to last very long. I watched one of these out west once when I lived in New Mexico, and within like 2 hours the water had risen and it had fallen and it was gone. So it's a pretty quick thing that can happen. And this is a flash flood that I watched in New Mexico. Notice the road there. Of course, normally the road would not be driving through all that water, but this was a flash flood that flowed through that area. Another thing I'd like you to notice is that there's no water here on the road. It didn't rain right there. What happened was it rained upstream a couple miles. And that's something you have to always be careful about with these flash floods. Remember what I said about drainage basins and so on, is that it could be dry where you are, but if it's raining a couple miles upstream from you, all that water is going to come downstream. And that's what happened here. There was a rainstorm a few miles off that way, and all that water then washed through here. And like I said, this was a flash flood, quick rise and quick fall. Now, that's very different from what we call downstream floods. These affect major parts of a river system. And so these are the kind where, large areas are going to be flooded, and they're going to be flooded for a while, for a long time. And these are caused by long-term weather patterns. So you might have a storm along a frontal system that stalls, and so it rains for days and days over a place. Or maybe you had a really snowy winter and then all that snow melts and causes a flood. But this is going to affect a large area of the drainage basin. This is in Frankfurt, Germany, and this happened to be a really, really snowy year up in the mountains where the water for this river comes from. And this is what it normally looks like there. And there we can see it in flood, right? So normally I'd walk my dog along here. Not going to be doing that at that time because you can see flooded in that area. And then this, of course, lasted for quite some time. This wasn't like, oh, it came and 2 hours later it's gone. We're talking days to weeks, and in some cases, even months. A classic example of one of these downstream, long-term floods that affected a large area was the Great Flood of 1993. Now what we're looking at right here, we have the Illinois River, the Mississippi River, and the Missouri River. And this little white area here, that's 5 kilometers. This is normal, where those rivers are flowing. This is in the Great Flood of 1993. You can see a huge area here was underwater from that flood. And like I said, this actually lasted several weeks. And again, there's our 5 kilometers. We're seeing like 5, maybe 10 kilometers away from the river was flooded. So this is something big. This is not a localized event. Floods can cause a lot of damage. This was a flood on the Black River, and the Black River actually flows under this little bridge here, but notice this flood took out all of that roadway there. And just to give you a closer look at that, the river is normally flowing down there, but in flood, that seemingly small river becomes very, very powerful and is able to even wash away much of that roadway there. So how do we study floods and understand them and try to figure out when they're going to happen and how bad are they going to be? Well, we have a way of plotting floods on a graph called a hydrograph. And this is a graph of stream stage or discharge over time. So look at the right side. The right side diagram is a hydrograph, and we have the stream stage, or it could be discharge. Discharge is the volume flowing in that river, and the higher we go, the more volume in there. And then we have time plotted on the x-axis. And I have 2 lines on there. The purple one is an upstream flood, a flash flood, right? It rises really quickly, falls really quickly as well. The blue line is what a downstream, a long-term flood would look like, right? It rises slower, sticks around for longer, and then eventually goes away. That's a hydrograph. That's what they look like. Now, with these hydrographs, why do we use them? Well, first of all, the floods, as you could see, show up as peaks. But if we have long-term hydrographs, ones that span years, or in some cases decades, we can see what the typical behavior of the stream is like. We can see how bad are floods usually, right? How in a typical flood, how high does the water rise? How often do the floods happen? Do they happen at a certain time of year? So if we have this long-term hydrograph, we can start seeing what the normal behavior of the stream is like, so we can get an understanding of what to expect in the future. Now, I do provide you with a website here if you feel like going to it. It will show you real-time data of hydrographs stream flow in the state of Texas. And so you can click on that, and then you can just look around and it'll show you which streams are in flood stage, which aren't. You can find hydrographs on there, but that's there for you to have fun with if you really feel like it. All right, now a different graph that we have is a flood frequency curve. And this is a graph of stream stage, or again, discharge, the volume of water in there, versus the probability of occurrence. So this is this other diagram here. So what we have on the y-axis is the stream stage, or volume of water in there, and then on the x-axis is the percent chance of it happening, right? The probability of it happening. So 100% chance, we know every year we're going to have this amount of water flowing in that stream. We have a 50% chance that there'll be this volume of water. We have a 10% chance there'll be this volume of water. So that's how they figure out that, remember, 100-year flood, 500-year flood, they'd be like, all right, 100-year flood is a 1% chance. So look, well, how high would the water at a 1% chance of occurring be? And that's how high a 100-year flood would be. So those are two ways that we graph our floods to try to understand the way these streams behave. Now, there is a problem, though, when we look at past behavior of streams and try to use it to forecast future behavior. Development, meaning building all these roads and houses and parking lots and stuff, that can change the typical behavior of streams. So you can have streams where they didn't flood often, and now they do because the urbanization has changed their behavior. So let's talk a little bit about why people live in floodplains. I know sometimes we're like, well, why would someone live in a floodplain? Well, I got news for you. If you live somewhere in Houston, you probably live in a floodplain. I mean, it's a slight exaggeration, but there's a lot of land around here that floods. So why do people live in floodplains? Well, the land tends to be cheap. The land tends to be fertile. And remember, a century ago, the United States was a farming country. That was the biggest thing that people did. They farmed. Well, where are they going to live? On the fertile farmland. Where's the fertile farmland? In the floodplain. Also, you have to think about, 150 years ago, no cars. How did a lot of transportation occur? By rivers. So people would build next to rivers because that's a major transportation corridor. So there are reasons why there are cities built in flood-prone areas. So don't just think, well, floodplain. I will admit it's a bad idea to live in a floodplain, but there are real reasons why some people do live in floodplains. So let's then talk a little bit about, like I said, streams can change their characteristics because of urbanization. And urbanization is building, like I said, roads, houses, buildings, parking lots, all that kind of stuff. Well, the big thing that happens when you urbanize an area is you cover the area with impermeable surfaces, right? That concrete of the parking lot, water can't infiltrate that. It can't penetrate that. That's what impermeable means. The water can't go through that. When that was soil, water could soak in and go join the groundwater. Now, can't soak in, can't join the groundwater, so it's going to join water in the river and start flooding things. Also, buildings, all the structures that we make, they occupy volume where water could be. The building's not there and no one cares if the water's there. Also, removing vegetation. First of all, remember I said vegetation can suck up some of the water and then give it back to the atmosphere in transpiration. If you remove all that vegetation, you don't get that happening anymore. Then the other thing is, the vegetation holds soil in place. When you remove it, you get increased soil erosion. And where does that soil go? It goes into the stream channel. So now, instead of having a stream channel that's maybe 6 feet deep, a whole lot of soil filled that up. Now maybe it's only 3 feet deep, right? Less volume of water can be held in that. And so we're going to get flooding that's worse than it used to be. So what we see right here, I know it's a busy graph, but there's a lot of stuff on there. First of all, here, this is the volume of water in the stream. This is time. And we're showing that we have rain falling right around this time. And our original hydrograph was this line right here. So you can see the water slowly rising. There's the crest of the flood, and then it goes away. After urbanization, notice the crest arrives a lot faster. And why does that happen? Well, you have all that water that used to soak into the ground and stuff. Now it's flowing over the parking lots, it's going into storm sewers, and it's going immediately into the river. It goes very quickly into our streams. So the floods rise much faster. And because we're getting more water faster, the crest is higher. So the response of a stream to urbanization is the floodwaters will rise faster and they will rise higher than the urbanized stream. So you could be someone who had a house sitting, I don't know, whatever this height above your stream was, like 50 years ago, no problem, you never flooded. But after things got urbanized around you, now you could be getting flooded where you never used to. And so in urbanization, the big take-home message is you cover all that land with impermeable material, your floods are going to be higher than they used to be.